Today's video is sponsored by Copilot, an affordable fitness app, but more on that later. Whether you need to start your car, survive the apocalypse, or rebuild civilization, the rechargeable lead-acid battery is a crucial game changer. With it, you can capture and store energy for use later, and if you pair it with a generator, you're basically building a power plant. So let's see what it takes to try and recreate this technology and see if I can build my own power plant and enter the age of electricity. I often get compared to the manga and anime series Dr. Stone, which explores a similar concept of rebuilding the technologies of civilization. And I previously explored some of the more far-fetched ideas of trying to make electrical wire. In this video, I'm taking inspiration from two devices they built in the series, the lead-acid battery and their primitive generator. In one of my earlier videos, we made the first form of the battery, the voltaic pile. This invention opened the door to the world of batteries and electricity, but these batteries were only single-use. Once depleted, there was no way to recharge them. Effectively, all the energy that is spent smelting the two metals of copper and zinc is expelled when the battery is used. In 1859, the first rechargeable battery was made, using a combination of lead electrodes and sulfuric acid. The dissolved sulfate ions and the lead will produce a chemical reaction to form lead sulfate and release energy. This reaction is then reversible, allowing energy to be put back into the battery and recharging it for future use. A few years ago, I made a trip out to Galena, Illinois area to collect lead. It was kind of a weird choice back then, especially with a modern understanding of lead and its toxicity. There's not really a whole lot you can do with lead. A fair amount was done with it historically, but it's not really the safest to work with. In the end, we really have only used lead for a slingshot. But besides being kind of the earliest metal that was first smelted and kind of paved the way for other metals, I also knew it was going to be really important for more modern applications, like specifically this lead-acid battery. So after a few years, it's nice to finally get back to this metal and what I had in mind when I first got it. And now I can finally make a battery using this metal. So basically with a lead acid battery, there's two parts. This is a little bit difficult to follow, but there's the lead and then there's the acid. Those are the two components for a lead acid battery. So now, thanks to our adventures a few years ago in collecting this lead and learning how to smelt it, we now have lead to work with, and we can actually start putting it to use for a pretty useful application of a rechargeable battery. What we're really trying to do is maximize surface area, because that's going to increase the amount of power we're able to generate with this. So let's take some of these ingots, melt it down, some are with good ventilation, and pour out some really flat sheets, and then hammer it even flatter, and then we can use these as the electrodes for our battery. Now we have our lead for our lead acid battery, and that leaves, hope you're following me with this, the acid. To make things even more confusing, it doesn't even actually have to be an acid. Apparently you can use sulfates, and these are basically salts formed from sulfuric acid. A lot of them are naturally occurring, and I've actually collected a few different ones, and we can test these all out and see what's going to give us the best result. So here we have concentrated sulfuric acid. This is sodium sulfate, and we collected this in Wyoming near Independence Rock. We collected water from this lake next door that was high in sodium carbonate, or soda ash, so it was very useful for making glass and soap, but on the shore tends to be a little bit more higher concentration of sodium sulfate. And then we have calcium sulfate, and this is basically drywall, plaster. It's the main chemical in those things. We collected these out of the crystal in Arizona, so that is also an option. The big issue with probably the calcium sulfate is it's not very soluble in water, so we're not going to get too much of it to actually go into solution, and it's probably going to prevent it from being too effective. But at least one of these should work, so I'm going to mix them into different solutions of water here, plug in our lead, charge up the batteries, and see which one is the most effective battery. So let's test them out and see what works best. As I go through on each of these and test it and can tell, I do get some voltage, but it's barely any, measured in millivolts. There might be some sort of residual charge, but it's minuscule or nothing. So let's put some current into them and see how much power they can store, and we can get back. We have our three different solutions of electrolytes connected with lead on each side, and that should basically make the battery. We're just gonna use a DC power supply here to charge them up. There's definitely some bubbles in the sodium sulfate. There's definitely a lot more in the sulfuric acid. I can't tell if there's any in the calcium sulfate. It's just so milky. All right, it's been about 20 minutes here. Let's see if we have any charge. All right, look at that. We got almost 2 volts there. Not too far off, 1.7 volts. Well, the same. Oh, got pretty good results. The results for all 3 were surprisingly comparable. So I'm gonna go with sodium sulfate, which is a pretty benign compound and a bit safer to mess around with than a bunch of sulfuric acid. When it comes to a battery like this, the amount of power and amperage you get is highly dependent on the surface area of the 2 electrodes. My first attempt, I figured I'd try to maximize that by kind of zigzagging them like this for each side. But then I found out that what also can maximize the amperage is the proximity of the 2 layers. And you can get them super close. Went through and coiled 2 long sheets of lead and separated them with a piece of linen so that they don't actually touch and short. And then wrapped it up. And we have that in here. So for both of them, their voltage is about the same, of about a little bit under 2. But this one I was able to get an amperage around a half an amp, which is actually pretty good compared to the other batteries I made. But with this one, I charged it overnight and I could actually get it up to, at least briefly, 12 amps. So that is really impressive for a battery like this. We're still a little bit of a magnitude away from actually making a car battery. That required a couple hundred amps. So pretty impressive with the amount of power that these guys can actually contain. So I think we're gonna go with the coil design and then we can make an array of these batteries to actually power something. I was able to make 13 of these coiled batteries. Depending on how I wire them, I could get up to 20 some volts. Not bad for a handmade battery. The end goal of this video is all about converting physical energy into stored electrical energy. But before I get started in charging my batteries, it might be best to charge my own physical batteries, as it's gonna take some physical labor to run this generator. If you're like me, you live a busy lifestyle where it gets challenging to stay committed to a physical training program. Life often gets in the way, making it hard to keep the routine, and any hiccup or doubt about the process can be an easy excuse to put off working out for another day. The past 4 weeks I've been using Copilot, and I found it really helpful to prevent these common hangups to building a new healthy workout routine. With Copilot, you get paired up with an expert coach to create a personalized workout program just for you, based on your own goals and the equipment that you have available. This works great for me as I personally hate gym memberships and their tricky membership terms. And my life is too busy and variable to have any kind of locked in specific time each day with a personal trainer. Copilot gives you kind of the best of both worlds, where you get the accountability and support from a real person with the flexibility to work out on your own schedule. Using Copilot has helped develop some healthy habits and gain a little bit more confidence in my fitness journey. Copilot is different from other fitness companies. It's not just an app, but a human connection with my coach. Their personalized workout programs and the flexibility to work on my own schedule have been a real game changer. Over 75% of Copilot clients continue to work out after 100 days, making them 9 times more successful at sticking to their goals. If you're ready to take charge of your fitness journey, click the link in the description to get your free trial with Copilot. So now that I put together an array of batteries that actually have a pretty powerful battery, that has some real potential. But at this point I've been kind of cheating because I've been using just modern electricity with a DC power supply to charge up and kind of measure the potential of these batteries. If you exist in a world without electricity, you can't really do that. And that's gonna be the second part of this video, is about actually powering it. So one potential is you do things like the voltaic pile. You make a chemical battery like this, where the energy is kind of stored, the chemical imbalance between zinc and copper. All the energy you put in to smelt all these different metals is then extracted through the reaction between them as they try to achieve a lower energy state. So that could be an option if you build a big enough voltaic pile. You can then use that to charge these lead acid batteries. But I think the more useful and interesting solution is going to be to actually build a generator that can then turn physical force into electrical stored energy. When we combine that with our batteries, we're basically building a power plant. Taking some inspiration from Dr. Stone, they build a very interesting one that is best compared to a homopolar generator invented by Faraday pretty early on in history. It's basically the first form of an electric generator. It's really not that powerful, and it's probably not worth trying to build. So I'm not gonna dive too deep into building this all the way, but I do wanna try and recreate roughly what we see in the comic and see if there's ways to improve it to make it a little bit more useful. And we can kind of see what the potential of this really is. So the basic concept of it is you have a big copper disc. In their case, they actually do 2. And then when you spin them, you also have magnets in between them. And basically, the interaction of the copper and the magnets kind of creates a flow of electrons, which then when you hook it up to wires, you get basically electricity. So that's one way to charge up the batteries. I'm gonna try that out and we can see how well that actually works. millivolts. That is not much. All right, so we got the pretty much completed homopolar generator as it's depicted in the anime. So as far as I can tell, I believe this is about the setup they had. Magnets are a little bit different sized. I don't recall them showing the wiring of it too much, but basically electricity is going to be generated between differences in the inner part of the ring and the outer part of the ring. Ultimately, the second disc is not really necessary. It's just I think double your output by doing it twice at the same time. Should be able to test this with just one of them. The effects of the magnet on the copper disc will cause kind of a flow of electrons, and there'll be some sort of difference between the inner and outer part. So then by connecting wires, we're able to complete a circuit that should hopefully generate some electricity. Let's give it a crank and see if we get anything. So we got it hooked up to both of them now. So we're basically one goes into the other to kind of should hopefully double the amount we get. I think that's the only purpose for having two discs. Doing just the one, I seem to get a relatively stable 5 millivolts, which is not a lot of voltage. And that's kind of to be expected with this design. It was never really used for any practical purpose. It was just kind of the first form of a generator that was discovered and then quickly replaced by ones that are a little bit more effective. In theory, it does seem to work. So let's see what kind of voltage I can get with closest replication to what they do in the anime. All right, that yielded about what I expected. I saw it go up to probably 30 millivolts, which is about appropriate for doubling it. But overall, this design is not really going to be the most effective. But I'm going to try and tweak it and add some improvements. So I made some improvements to the generator here to see if we can get a little bit better result. The other one was basically a replication of the Dr. Stone model. Had some success in getting at least something, but not very much. So this has basically improved the things that's a little bit more sturdy. I got a threaded rod here. Rather than the large magnets on each side, I switched it with a couple hundred small, really powerful magnets. It's actually kind of a huge pain to glue all several hundred of them along the diameter of these wood rings and try to get them to actually hold there where they want to push each other away was a lot of fun. And then because there's still a little bit of a gap between them, I put pieces of sheet metal, cut them to the shape of the disc here, and kind of hopefully kind of average out magnetic. So we get a relatively consistent magnetic field all along the perimeter of here. And that's probably the biggest shortcoming of the Dr. Stone design is we have the magnets just in one section, and then the rest of the rotation, it's kind of losing the charge. So here we have a consistent magnetic field all the way around it. It's definitely an improvement, but it's not nearly as much as I had hoped for the amount of effort of trying to build this. It's been a couple weeks now of just tweaking and trying to get this thing to work and trying a few different models. I found doing kind of more miniature ones seem to be able to get a little bit more consistent voltage out of it. I think is going to be the main limiting factor as far as I can tell. So I've been trying to do a few different versions of this to try and address potential shortfalls of this. And I'm really kind of drawing a blank on what exactly is not quite working out. Because the results I'm getting from all of these is not as high as it's supposed to be. And I don't know if the copper is too thin, if it's just too flexible and I can't maintain good contact with the brushings. I know it's definitely an issue here. Try gluing some wood to the disc to be a little bit more rigidity. Try different powers of magnets. It's very frustrating, I have to say, because this is a device that was never really had any practical use. So it's kind of annoying to spend a lot of time trying to get it to work for something that's not really of any value. Trying to get it to work as best as possible, and it's still falling a lot shorter than I hoped. Unfortunately, these batteries are actually surprisingly potent. I have so many of them that I can stack the voltage between them. So after charging each one individually, I should be able to connect them all together and hopefully get some kind of voltage is usable. I think we're probably looking at least 1 volt to really do too much. Light up a nitty bitty LED. Got most of them charged up and connect them together and see what exactly we can get out of this. The end result of all of this work and all these different generators to try and power up my battery is under a volt, and that's pretty disappointing. I was hoping to at least get a few volts, especially when everything is stacked. we're at maybe 0.7, which means just a fraction of a volt in each of these that's being stacked to actually make anything. And the end result is less than a AA battery. This is just a first step, and I kind of just wanted to explore the whole Dr. Stone generator. It's a very interesting concept, just how simple it appears with a magnet and some copper discs. It does work in theory. We are generating some amount of electricity. It's just very minuscule. Actually making a generator like this primitively and expecting it to actually have some value is pretty far-fetched. It does have, in theory, some potential. There's just so many things that can go wrong, and I think I managed to do all of them. The lead battery, though, itself is actually, I would consider a pretty good success and something I'll be using again in the future, hopefully with a more efficient generator sometime soon. Very impressed with the results from the battery, very unimpressed with the homopolar generator. So when it comes to electronics, that's gonna be the next goal, is building a generator that way can actually power a battery a bit more and then start using this battery for some further electronic work. Thank you again to all of our supporters on Patreon. Without you, this channel wouldn't be possible. Thanks for watching. Thanks again to Copilot for sponsoring today's video. If you need some help recharging your own battery, consider Copilot, an affordable fitness app. The last 4 weeks of using it myself have been incredibly helpful for building a healthier routine for myself and improving my own strength with some customized workouts for my personal trainer. It's easy to get distracted and dissuaded from building a good routine, and Copilot helps you get past that with your own expert to keep you accountable and address any questions or doubts along the way. Start your fitness journey with Copilot today. Check out their app now and make some first steps towards a healthier you. If you enjoyed this video, be sure to subscribe and check out other content we have covering a wide variety of topics. Also, if you've enjoyed these series, consider supporting us on Patreon. We are largely a fan-funded channel and depend on the support of our viewers in order to keep our series going. Thanks for watching.